Okay, welcome to 2.2. This is a review video on long division, synthetic division, and the introduction to the box method. When you're dealing with fractions, if I said 2 times 3 equals 6, then you would say that 6 divided by 3 would be 2, because 2 and 3 are factors of 6. So in the same way, if I said that x minus 1 times x minus 2 equals x squared minus 3x plus 2, then I could also say that x squared minus 3x plus 2 divided by x minus 1 would equal the other factor. And that's division. And that's what we're trying to do here, is the same thing that we do with fractions, we're going to be doing with algebraic expressions. So we are multiplying them together, those make those factors. And just like sometimes, like if I said 7 divided by 2 does not come out evenly, right? It's equal to 3. 2 goes in there three times with 1 left over. So in the same way, when we divide polynomials, we are also going to have a remainder sometimes. If we do not have a remainder, then it is a factor. If we have a remainder, then it's not. So it's pretty straightforward. And you probably remember all of this, but I'm going to work a few examples just to refresh your memory, because this will be the assignment for tomorrow. And in case you have questions, then you can refer back to the video. Okay, the first thing that we want to do is remember long division. So I've given you this problem here, x to the third minus 4x squared minus 17x plus 6 divided by x minus 3. And I'm going to write the division problems in various ways so that you can see all the ways that you can write them. But to divide using long division, it looks just like a long division. You write your number underneath. And we're going to divide by x minus 3. And for the first number, we're going to say x times what is x to the third? X times what is x to the third? Well, that would be x squared. And then we're going to multiply. X squared times x is x to the third. Negative 3 times x squared is negative 3x squared. And then we're going to remember to change the sign and add. So when we do that, negative 4 plus 3 is negative x squared, and then we bring down the next term. And we do the process again. We say x times what is negative x squared, and so we write minus x, and then we multiply. So negative x times x is negative x squared. Negative times a negative is a positive. And then we change signs and add them together. So we have negative 20x. We bring down our last number, and we ask ourselves the same question again. X times what is negative 20x squared? And so that's going to be minus 20. I'm going to have minus 20x plus 60. And then I remember to change my signs. So these are going to cancel, and then I have negative 54. So this is not a factor. X minus 3 is not a factor of this polynomial because I have a remainder. So you will write this x squared minus x minus 20 plus, and you could do minus if you wanted to, negative 54 over the divisor, which is x minus 3. So this part right here is the remainder. Okay, this is, even though it's written a little differently, the same problem as the previous screen. But I'm going to show you an alternate way to do this problem. I also want to show you that this to the negative 1 power, remember that anything to the negative 1 power right here, anything to the negative 1 power is just written 1 over the same thing to the positive power. That's just another way of saying divide this polynomial by x minus 3. It's just another way of saying it. So the box method looks like this. I have my divisor, x minus 3, and I write it here. Now, the box method looks like this. These are rows, and these are columns. And just like in a spreadsheet, I would say x times what gets me what's inside this box. This number times up here on this box. In fact, let me just show you, this is multiplication, but you can kind of see how it works here. So I have x negative 3, let's say x and 2, x plus 2. So if I wanted to multiply those two binomials together, I would say x times x is x squared and write it in here. I would say x times 2 is 2x. I would say negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. And if I combine like terms, I have x squared minus x minus 6. So you'll notice that these got added together because they were like terms. And that's what you're doing here, only you're working it backwards. So you're saying that x times some number is x to the third. So this number right here gets put in this box. That's how you always start it. And you say x times what is x to the third? Well, that's x squared. X times x squared is x to the third. And then you write in this box, negative 3 times negative x squared is negative 3x squared. Okay, I know that this box and this box have to add together to get the next term, the x squared term. Well, I have negative 3x squared, and I need negative 4. This is negative x squared. And then you ask yourself again, x times what is negative x squared? So this would be negative x, and multiply to get this box. Negative times a negative is a positive 3x. The next term is negative 17x. Well, I have 3x. So in order to make that a negative 17, I would have to add negative 20x. And you ask yourself again, x times what is negative 20x? And that would be negative 20. Negative 20 to get this box times negative 3 is a positive 60. All right? But my final term in my polynomial that I need to get is 6, not 60. So I'm going to have to subtract 54 off of that, and that is my remainder. So just like in the previous problem, x minus 3 times x squared minus x minus 20 plus negative 54 over x minus 3. Okay, everybody's favorite, synthetic division. Most people like this better than anything else. Synthetic division is used when the divisor is a linear term. In other words, if this were x squared, then you probably would not use synthetic division. Although I have seen it done, it's not often done. So your factor, even if it's a 2x minus 3, you can still use synthetic division. All right, so here's how I do synthetic division. The first thing you do with synthetic is that you always write the coefficients. You never write the variables. So I start in order and I watch for missing terms. So I start with x to the third, that has a coefficient of 1, and then negative 4, and then negative 17, and then 6. And I'm noting x to the third, x squared, x, and no x. So there's no missing terms. Over here is my divisor. Now this is a factor. This is not the 0. What goes here is the 0. So you set that equal to 0, this would be a 3. Be very careful that you do that. The next thing that I always do is write an arrow, because that reminds me that I don't do anything to the first coefficient except bring it down. And then I'm going to take 3 times 1 and write 3 here. And then I'm going to add them together. So this will be negative 1. All right, then I take 3 times negative 1 and write it here. So this would be negative 3. and then add them together. So this will be negative 20. And then finally, I take 3 times negative 20 and get negative 60. And when I add those together, I get negative 54. All right, so this should look familiar. It's the third time I've worked this problem. This is the remainder. This is the constant term. This is the linear term, x. And this is the quadratic term, x squared. And it goes in order like that. So it should make sense that if you divide an x to the third by an x to the first, you're going to end up getting an x to the second divisor. So I have x squared minus x minus 20 with a remainder of 54 written over the divisor, which is x minus 3. Same deal here. It is the same deal here. So this is synthetic division, and I'll do another example here in a minute. This is an interesting problem because when you're dividing this using synthetic, you have an unexpected thing happen at the end. So let's go ahead and do this with long division. I'm going to do the box one more time. To give you another example of this. When you use synthetic, it does something kind of unexpected. So you write the divisor here, remembering that this is the box where you start, and you always put the first term inside the red box. So I would write 2x to the third. And then you say to yourself, 2x times what is 2x to the third? Well, that would be x squared, right? And then you're going to multiply down here. So I have negative 3x squared. Moving to the next term. Well, negative 3x squared, I already have one. So I need a 0x squared. Adding these two terms together will get me this term. Adding these two terms. All right, so I say 2x times what is 0? Well, that's easy. That's just 0. 0x, 0. And so 0 times 0 is just 0. 0x. So now we're ready to move to this term. And we know that these two terms are going to have to add up to negative 50x. So 2x times, so I'm going to write, oh sorry, I forgot to write the negative 50x in here. What's a negative? 2 times negative 25 is negative 50x, right? And then I need this one. So this is going to be plus 75. And then I look at the final term. Final term is 75, so there is no remainder. There's no remainder because the 75 and the 75 are the same. All right, so the answer is 2x to the third minus divided by 2x minus 3 equals x squared minus 25. In other words, 2x minus 3 times x squared minus 25 has to equal my original problem here. And it does. All right, so let's do synthetic real quick. I've got 2, negative 3, negative 50, and 75. And I'm going to divide by the factor, not the factor, but the 0. The 0 is going to be positive 3/2. And I got that very quickly by setting this equal and solving. Okay, so I bring this number down to 2 times 3/2 is just 3. Negative 3 times 3 is, or add those together is 0. Then this is 0. This is negative 50. And then when I multiply that, I'm going to get 75 negative and 0. So once again, I have a remainder of 0. So 2x minus 3 is a factor. But look at this. This is different. This is 2x squared minus 50. Well, if I write the 0, if I write this 0 as a factor, just like it's written, that would be x minus 3/2. Well, that doesn't exactly look like my original divisor, But something interesting, if I factor out a 2 from this right here, right, this would give me x squared minus 25. So I have x, well, that slipped. I would have, if I factor out a 2, and of course I've run out of room, 2, I'm not, 2, 2, okay, x squared minus 25, and then I have x minus 3 halves. If I multiply this times 2, I end up with x squared minus 25, 2x minus 3, and that's what I ended up with the long division using the box method. So it was a little unexpected, but I noticed when I worked it, that's what that meant. Here's a polynomial that has some missing parts, a lot of missing parts. So if you were going to do synthetic division or long division or box method or whatever, you would have to take into consideration that it's missing several of its terms. In fact, it starts at x to the fourth and goes all the way down to the constant. So it's missing the cubic, the quadratic, and the linear. 3 terms. And you're dividing by something that looks like this. So, for instance, if you were going to do synthetic division, you would have to do 8, 0 for the cubic, 0 for the quadratic, 0 for the x, and a negative 5. So you would actually have to have a placeholder. Okay, if you're doing the long division, you would need to do 8x to the fourth plus 0x to the third plus 0x squared plus x, 0x, minus 5, and your 2x plus 1. Okay, if you were doing the box method, I would still have it written out like this before I did my box method. If you did 2x plus 1, right, and you always start with 8x to the fourth here, 4x to the third, and 4x to the third, then this would have to be negative 4x to the third, right, because these two together would have to be 0x to the third. So you would do negative 2x squared, which would get negative 2x squared. Once again, these two right here would have to be 0x squared, so this is going to be 2x squared, right? And so this would be 2. No, I did that wrong. This would be x. Yep. Okay. Because x times 2x is 2x squared, and then this would be x. There are no x's, so this is negative x, right? So right here, there are no x's, so these two have to add up to 0, which I'm pointing, but you can't see me. These two have to add to 0. So 2x times negative x, 2x times what? Well, that would be a negative 1/2, which is ugly. And then this would be negative 1/2. And then I look at the last terms and I see, okay, it's not a factor, they're not the same. In other words, I need to add another 4.5 to get 5. And so that would be 4 1/2. 4 1/2 is 9 halves, right? So that's my remainder. So this is the remainder. So no matter how you do it, the answer is going to be 4x to the third minus 2x squared plus x minus 1/2 with a remainder of 9 halves, negative 9 halves. And so any way you do it, notice the placeholder. Okay, so that's it, and you'll have some problems in class to work. I hope that you've worked through these and that you've remembered them, and we'll look all that over when we return.